So today I'm gonna kind of talk about these new functionalities that are still not in the main system. So that's why you need to install this package for LLM functions. So LLM stands for large language models, which probably all of you by now have tried, like ChatGPT, large language models. It's kind of a kind of a trending topic nowadays. So the outline for today's kind of presentation, it's going to be first of all, I'll start with some functions, basic ones on LLM synthesize, and there's going to be as well some other functions from like LLMFunction and LLMExampleFunction. These are experimental functions for few-shot learning. Few-shot learning stands for you kind of large language models can be few-shot learners, and that means that if you show them a few examples, they will in context learn without the need to train the model again. And with this, we can do we can create several functions that can be already like applied to the Wolfram language and have some useful use cases or applications for them. So probably so if you have been installing this package, this already works on 13.2 of Mathematica, I think, which was released on last December. So the version should be 1.08. And we'll start with LLM synthesize. So that's basically what you would get on querying, for example, ChatGPT on like, give me a short poem about a boar, and you get back the answer from the LLM. By default, LLMSynthesize uses temperature 0.8. The concept of temperature in LLMs comes from the physics temperature, since the kind of it's a sampling formula which will give you with temperature 0, it's going to be deterministic theoretically, and with temperatures above, it's going to be the model will be a bit more creative, and you will get different answers with the same prompt, let's say. So, for example, here with a temperature of 1.5, you will get multiple different answers. While if you set up the temperature 0, you will get over the same answer. With exception, sometimes there is some GPU technicality that it might be the case that it gives you different answers, but it's a way to control the output of the model. By default, this is taking the ChatGPT default model. This is the Turbo GPT 3.5 model. But for those that have access to the GPT-4, you can also set up, change the model, for example, to use GPT-4 with LLM evaluator within the LLM synthesize. So this is the same with the same prompt, short poem about the boar, but it's a bit longer and different than before. Another kind of function within this packlet is image synthesize, which given a textual prompt, you can, and in this case is the DALL-E model, but in the future we will also want to add the possibility to change it to other models like Stable Diffusion, Midjourney, and the same for LLMs. Right now, it's they are like OpenAI models, like GPT 3.5 and GPT-3, and I think it's GPT-4 as well, but it could be in the future that we will have the possibility to switch models and go to and use the BART model from Google on other ones as well.
Jofre,
Yeah.
sorry to interrupt you, but a few
Yeah.
quick questions that have come up on Q&A, and I think it would be good to get them out of the way.
Okay.
Folks are already trying the Packlet. First, the Packlet is now publicly available, right? So there should not
Right.
be any errors for not being able to install the Packlet. If you're running into errors, our recommendation would be just to try again. Maybe the connection was not okay. And the second is once we try to run it, some folks are getting service connection error, failure, service OpenAI unknown.
Right.
So that means we need to connect to the OpenAI service. Can we do this on 13.2?
Yes, it should be possible. Right. I don't know how to fix this problem, but mainly maybe it should be updating the service connection Packlet could be
Okay.
a possibility. Also make sure that they are using 13.2
Okay.
version.
And the command would be service connect OpenAI.
Yes,
Okay.
Service Connects OpenAI and
And then the last question, I won't interrupt for too much longer. So with Service Connect OpenAI, the credentials that you would need to provide would be your ChatGPT account credentials.
right. So like a normal account on OpenAI, you would have the credentials somewhere there. I don't remember exactly.
Okay.
Like
Thank you so much.
I would need to go to the site, but yeah, they're like somewhere the credentials
Okay.
on
So I
the
hope,
profile account there. Yeah,
thank you. So I hope that answers some of the basic questions, and we'll go ahead with the presentation. Thank you, Jofre.
no problem. And then interrupt me if there's more questions relevant for it. So like image synthesize also have the options to for like outputting different image sizes, and also it can given an image, you can also generate a similar image that didn't exist before. For example, this parrot, this one would be kind of generated by DALI model, DALI 2 in this case. So let's jump into the LM function. So this is kind of a new function that we've been kind of working on, that on temperature 0 for this like simple example, it would be like the same as LLMSynthesize. So you give a textual prompt, and in this case, the LM function, it's always returning a kind of a template object plus an interpreter. In this case, if the interpreter is a string, it just means that you into the slot you have a kind of a string join the kind of the query. In this case, it will generate a prompt, a textual prompt that would be like the same as LLM synthesize, but using temperature 0. And the cool thing about LLM functions is that you can specify different interpreters other than that, just a string. So for example, you can create this simple simple LLM function for kind of give me the opposite of the color blue. And in the second argument of the LLM function, you can specify the interpreter. In this case, the interpreter color will try to identify a kind of a color in RGB in our system. And for those that you are not familiar, but interpreter has multiple data types that can be interpreted. For example, country, it will try to give an entity for the country. The same for like JSON, and there's like multiple types of interpreted data. So I recommend you to also to explore the documentation side for interpreter. So here, LLMFunction also accepts multiple slots. So for example, is 2 bigger than 1? Answer yes or no. If you give a list of different strings, this would be string joined. And in this case, since we added like two different slots, it will kind of use both kind of variables. Also, one can use names on the slots instead of being kind of just numbered slots. In this case, for example, you can name the slots as phrase and tense, and you can have this simple example of kind of converting a sentence into different kind of tense. So another thing that can also accept LLMs function is the LLM prompt. These are kind of a symbolic prompt from the prompt repository. This is already a repository that it's out there, and we're kind of creating more prompts every day there. And for example, there is this LE5 explain me like I'm 5 years old. Which can kind of the LLM prompt can be combined with other queries, user queries. So you would be able to kind of with LLM function to create a function that combines this default prompt from the prompt repository and answer a particular question. For example, how far away is Mars? And it's trying to explain it for a 5 years old kid. Yeah, I added here the link so you can go to the prompt repository and explore a bit there the different categories we have so far, like personas, function prompts, and modifier prompts. And it's going to be working. It's going to work similar to the Wolfram function repository, but for prompts. Another way to use the LLM function is to also specify in which type of data do you want the output to be. In this case, I'm using kind of Wolfram Language pseudocode, since this would be like a zero-shot learning example. I'm not really giving an example, but I'm giving the structure that the output you should have. So here I'm telling it to only use Wolfram Language as output, and that the structure should be a list of associations for colors, and then adding the main kind of prompt, and also adding the slot here, so I can get the most fashionable colors in a certain year. And in the second argument of the LLM function, I'm also like using this interpretation, so automatically it will return me the RGB colors in a list. In a similar way, we can do a bit more complex example. In this case, I'm asking for a kind of a list of associations having multiple kind of properties. And in this case, I'm asking it to kind of return the answers as an association with the name of the person and also the term for the kind of US presidents between certain periods of years. So and this is the already like answer we're using the interpreter for name for the person. So it's for notable persons we have entities on, for example, for the presidents, they're already there, and then also interpreted for dates. So we have the start date of the president and the final date between this period. So this is another example I kind of created, also using zero-shot learning. This was it was a prompt to extract mainly like questions from a text or a piece of text, or like, for example, an interview. And in this case, I was using I think it was 10 minutes recording from a Lex Friedman interview with Stephen Wolfram. So I wanted from this transcript, automatic transcript from the YouTube channel, to pick up all the questions that are there. If you can see, as you see, that there's no question marks within the text, since it's an automatic transcript. So it was a cool experiment to do that. Using this specific prompt, I was able to kind of specify the LLM to return as a list of questions. So then I think I was just interpreting it as an expression and displaying it as a column. So it returned all the kind of, I don't know if it was all of the questions, but it picked up like multiple questions that were within these 10 first minutes from this interview. Another thing that it was cool to experiment with was kind of creating prompts with LLMFunction that then they would be like used for the image synthesize. In this case, DALL-E 2 would generate. So you would it's a way to enhance a prompt for image synthesizing them afterwards. So in this case was that kind of write a detailed prompt under 1,000 characters. Otherwise, it could be longer than the prompt length that image synthesize can accept. And then I was adding a couple of slots there for the kind of the type of animal that should be there, and also the artwork should be in a style inspired by some artist. In this case, I was testing it with Beatrix Potter, and the animal was a Triceratops, and the kind of object that was smelling was a fern. And the same for kind of a hedgehog smelling a mushroom, and the artist inspired by Salvador Dali. Another example here with LLMFunction is one to write a tweet about a certain topic, as it was written by kind of a famous person. In this case, I was doing some tweets on nuclear bombs and Albert Einstein. I think this is a famous quote from him, or at least partially. And it even adds some hashtags. The same I was doing for Rural Space and Stephen Wolfram and Alan Turing, and the results are nice. So so far, these were like LLM function examples. So the LLM example function, it's basically the same as the LLM function, but here it's where we want to also include specific examples. So the model will learn by context what type of output do you want to obtain. It's a way to improve the results if you want a specific type of output. So I also included a kind of a link to a famous paper on this specific prompt engineering topic, on that explained that large language models are few-shot learners. That's a kind of an emerging capability of these models that smaller models don't have. And it's still not fully understood how they are able to in context learn that well. But that's something we can exploit, and hopefully you will see some cool examples here. So this is a super basic example. Basically, to introduce a list of examples for this LLM example function, you can introduce them as key values, like in for example, the classify function in built-in system. So there is the first example, for example, here would be the input would be the boy played chess, and I want as an output to indicate that the main character in the sentence, or it's referring to a male. And then another example where the woman was driving a Tesla to be classified as a female. So and this would be like the prompt from the user. So she likes cats, so it correctly output as a female. Of course, for example, if I'm asking something more ambiguous, like God, the LLM in this case it's complaining. So probably we should also include not applicable example in our list of examples. So this is another example I did for like kind of extracting kind of data from unstructured text. In this case, it's personal, like extract personal data from a paragraph. So in the prompt here, I'm first including what it would be like the task description of the of the prompt, and then I'm giving in this case I'm going to give one example of input and output, and then the final kind of query that would be like the text that the user would use for the function. In this case, the task is replace personally identify information in text with Wolfram Language list of associations. And then I'm giving as an input a paragraph with kind of personal information for two different persons. And then as an output, I'm giving an association which I'm converting into a string for the prompt as input form. And finally, also I'm asking it to convert into expression the text. So the interpreter is going to be an expression, a Wolfram language expression. So this is the kind of the prompt template for the LLM function. And you can see the structure of this LLM example function, which is the main task prompt. And then there is the first input for the first example. Actually, I'm using only one example in this case, and the output format. So with this, we can ask to kind of obtain this kind of personal information with this particular structure. And this is a new paragraph, and it correctly picks up also new personal data. So this works also for unseen personal data types. So for example, if we're going to the Wikipedia, we can use the Wikipedia data function and ask for, like, for example, Alan Turing, and give me the summary plain text of the Wikipedia page for it. And it returned this data set with different kind of personal data from it. So it's quite nice. And the same kind of type of example, but in this case, instead of using expression in the interpreter, here I'm using a string template. And in the example, the output for the first example, instead of a list of associations, I'm using slots for like the the personal data. So in this case, this function is gonna given a piece of text, it's gonna kind of delete the personal identifier, the personal information, and create a template object replacing them with some slots, template slots. So the template that generates, for example, from this piece, it's going to be, it can be then applied to different personal data. This is another example kind of I did using this LLM example function. And here the main idea of this example was to kind of obtain kind of different types of colors giving a certain topic or a certain kind of a specified type of even like colors that are not kind of common in the English language. So you could ask for like interesting. So this was the examples I created, like for interesting colors from tribes living in the Amazon, and this that would be like the example input, and the example output would be kind of this list of this association with the color names and also the phonetic transcription of the color, as well as the description of the color and the language that it comes from. And with this kind of, and as well as I think I'm adding here the approximate RGB color in Wolfram language. So with this example, with this kind of, this is the structure of the example output. We can, and this is the second one for colors from this particular language, which I don't know how to pronounce, but the final kind of LLM example function using these examples with the main task, the example input, and then the example outputs for these two examples. And in this case, I was using, I think I have to replace here this was an old version of this function, but I was using the GPT-4 for getting better results. I don't know how good it's gonna be with the default one. I have to try it. But this is the LLM function with the examples, and here there's like some test I did on this function. For example, colors from Australian Aboriginal languages that do not have a translation in English, and it was giving me a list of several of them, and it was nice to kind of to learn about these Aboriginal languages. And typically, they're kind of, these colors are related to the environment, the natural environment of these tribes. And the same for like 10 different types of white colors described by these Espigule languages. I don't know if I pronounced correctly, but basically are the different languages from Eskimo culture and they have quite a lot of sophisticated names for white type colors there, since mainly the landscape it's kind of mostly white due to the snow. The same for this other example on kind of 7 interesting colors from ancient Greece, and some of them were like since the Latin kind of my mother tongue is Catalan, and we still have some words taken from Greek and Latin. Some of them were like familiar. Okay, let's jump into another LLM example function. This case is to extract a kind of date objects or date events from text. This was the example I was using. Yeah, this is the main task prompt, and this was the one shot example for this prompt. Basically, it was a piece of paragraph from Albert Einstein, from I think it was from the Wikipedia page, and then I returned a kind of a list of pairs from kind of date events from this text. In this case, I'm asking it to return date objects on certain events. And in the second argument here, using the interpretation for the date object as well as the location, if it's available. And finally, the result was like for like the same Wikipedia data that we used before for Alan Turing. I could extract kind of all these dates and also locations from the Wikipedia page, which it's nice to be able to do it automatically. And then from this data set, we can create a timeline plot, for example, like this. Other type of examples kind of I did is to also kind of convert external code into Wolfram language. This is highly kind of experimental. For some functions, it's not going to be kind of producing runnable code, but for this specific example, it was working well. Basically, I'm asking it to translate MATLAB programming language code into Wolfram language. So the input example is it's a piece of MATLAB code for generating this plot, and then the kind of the output example would be the Wolfram language expression to plot this function. And in the interpreter here, I'm using health expression since we don't want to run the code generated. Sometimes can produce some errors, so we just want kind of the input code, but without being evaluated. So in this case, I was testing it for this MATLAB function to plot this particular surface. In this case, after doing release halt on the expression that was returned by this LLM function, it was correctly converted to the same plot from the original, of course, with different kind of plot stylings from Wolfram language. Then I did some experiments with a graph as well. So let's try to generate some graph out of LLMs. So in this case, I was kind of using this example on kind of it was a knowledge graph on kind of narrower terms for pcats. So all these are like key values. You could say that these are edges for this kind of knowledge graph, starting from big cat and then giving the different kind of narrower terms for these big cats, like the Panthurium, and I think here there's like all kind of types of tigers, lions, and other type of big cats. So this was the main task, and then I was using only one short example. For sure, if I was adding more like kind of examples, it would work better. But it was already like giving some nice nice results. And in the kind of section for the interpreter here, what I was converting the output from this LLM function into an expression, and then returning like applying directly a community graph plot, since it has already like the structure for being a graph. And in this case, I think I was using as well GPT-4 and temperature 0, which is the default one for LLMExampleFunction and LLMFunction. So here there are like some other results on using this function. For example, the narrower terms graph for several automata, it was giving something like this. It was nice for kind of exploring what's the knowledge of GPT-4 on this topic. The same you can ask for like terms like the concept war, and it will try to give you like some narrower terms for it. And yeah, I think I have some examples there. This is another kind of application I tried. Was okay, given so you can ask the LLM to output specific URLs given a specific structure. For in this case, I wanted it to give Wolfram Alpha queries. So you could just kind of apply a hyperlink on them, and then be able to go to Wolfram Alpha and check some examples on a particular topic. So, for example, ask some relevant questions about the moons of the solar system, and it gave me several hyper kind of links to Wolfram Alpha, and I think some of them were like working nicely. A number of moons in the solar system, and I think could be that some of them were like not there, but overall I think it did a good job. Like a smallest moon in the solar system, I had no idea about it, but it looks like pretty small. Dimorphos. And I think it was the last one, that moons with atmosphere, which was not returning a proper answer. Oh, but it gives the atmosphere from of the moon, so that's nice. I think I'm reaching to the end of the examples, but I have another one using kind of this LLM example function to solve physics problems. So what a common kind of problem that had ChatGPT is that if you ask it some calculations, it typically hallucinated or did just the calculations wrong. So in order to avoid this limitation, here what I'm asking is using this kind of few-shot learning scenario, is to give me only the kind of the calculations that he would do, and then run these formulas on Mathematica. So in this particular case, I was giving an example on kind of kinetics energy, and I think I was using only one example. Yeah. So that would be like the problem text, and this would be like a way to solve it using Wolfram language with this kind of using quantity. And then this output, I'm using an interpreter for like converting the string into an expression, and then converting the units to the main, to the so it will give you already like with unit converted to the main unit that typically is the answer for the physics problem that you want. So in this case, I was then using a problem for, I think it was a college problem on physics, which was not doing well on ChatGPT by kind of by default, since I think it was trying to do some calculations, and in this case it returned the right answer by basically giving you the code or like the calculations in Wolfram language, and then this function just evaluates it to the right answer and units. And the same for this other like simple example. I think with this, I'm kind of, I finished the list of examples, but there are like many more in the prompt repository. So I recommend you to start kind of playing with them. And I don't know if I skipped some section. Yeah, probably I had something else. Yeah, maybe I can go to the Wolfram prompt repository. Yeah, maybe I think I added the link wrong, but basically it's this one. And here, if you have some cool examples, you can also submit them. There was also this blog post I did before all these LLM function and LLM example functions were developed. So here I was using directly the kind of the LLMSynthesize, the previous version of it. But I was giving several examples on, or actually I was using only one short learning example on cooking recipes. And from the cooking recipes, I wanted to extract all the ingredients and also then generate, interpret the ingredients with the interpreter of food, as well as using quantities. And then I think I was able to generate, to compute like how many calories does a certain recipe has, as well as the knowledge graph for cooking it, and all the different steps to get to the final kind of recipe meal. And I think I did the same with some variations. Yeah, I used DALL-E to also generate images of the meal or of the cooking recipe. One can include like mix all the ingredients together, and sometimes it generates an image that it's similar to the final recipe, but that's not guaranteed in this case. Or you can also do an image collage of the ingredients, the food ingredients separately. And it was doing a nice job on it. And also, I think I had some example on doing the reverse, like you give a specific kind of meal without specifying the recipe, and it will try to generate the same kind of cooking knowledge graph of the recipe, and even generate some. I remember that there was some problem here, since I think there was like chicken breast. DALL-E 2 was complaining that the word breast was kind of dangerous or problematic, and it should not be. But of course, it was associated to chicken breast. And I think that's all. I think here I was also giving an example on, you have certain ingredients for cooking on your fridge, and ask for like, generate me a specific recipe. Just do the experiment on your own risk at home. Don't try it with weird ingredients. But that's all. So with this, I will finish the presentation.